Welcome to this introduction of the web with NI software. We'll be taking a look at the basics of HTTP and how we can generate dynamic content in web services to be displayed in G Web applications. During this presentation, we'll be looking at a basic overview of HTTP to understand the relationship between clients, servers, and web services and G Web applications. We'll then take a look at the basics of web services and how we can generate dynamic data with them, and then there will be a handful of demos that will demonstrate these capabilities. HTTP is short for Hypertext Transfer Protocol, and is an exchange of messages between clients that make requests to servers that generate responses. HTTP runs on top of TCP, and for the most part represents human-readable content. HTTP clients are any software that communicates to other software through HTTP, and can be anything from web browsers to custom-built applications. TCP's addressing and ports will be useful in understanding how clients can find servers. For this presentation, we just need to understand the separation of clients and web servers and how web servers can represent resources. HTTP messages follow a specific format and are the means by which clients can request resources and servers will provide responses back to those clients. Resources are identified by a URI, which is short for Uniform Resource Identifier. Wikipedia has a great article about URI formatting and what sections are contained in a URI. Also included in an HTTP message are the headers that provide additional context and information for the request. A payload, aka a body, is optional in an HTTP request. In an HTTP request, the first line is comprised of a method, the target for the request, and an HTTP version. In this example request, we can see that the method is get. The target resource being pointed at is the path identified by podbaydoors/open with a query string of pilot equals Dave. And then finally, the HTTP version is 1.1. After that, we'll follow a handful of headers in the format of the name of the header, a colon, and then the value. For example, here we have host HAL9000. This is typically sent by browsers informing the server what hostname it used to request the resource, and then there may be other additional options such as accept language, which describes the language it expects a response in. If there is a payload, there will be a blank line between the last header and then the rest of the payload. In the case of a response, you'll again see the HTTP version and then a status code followed by the text of the status message. Servers, or more specifically web servers, are software that's running on a system identified by an IP or hostname and the specific port that that software is listening to on that system. Server software typically provides access to resources, whether they're files, devices, or other software that are accessible to the machine that is running that server software. As an example is the NI web server. Other example web servers are the Apache web server, Node.js, Nginx, IIS, Lite, and there are many more. Web clients are any application that initiates requests to server software using HTTP. Examples can be web browsers, web apps running in browsers that may make requests, and LabVIEW applications making use of the HTTP palette that you can see to the right. Clients will need to know the address, whether it be the IP address or hostname, of the machine running the server software, and optionally, they'll need to know the port that that software is listening on. Protocols such as HTTP, FTP, SSH, and many others have well-known standard ports that do not need to be specified in a request. LabVIEW Web Services are collections of VIs that can be run to handle requests made to a web server. Additionally, web services can also serve static content. VIs in a web service can access information about the request, such as the post data, form content, client information, and URL that was used to access the resource. Under most circumstances, a resource VI will write string data back to the client. Examples of this response data can be a string representation of data available in a LabVIEW app, which it may pull from a functional global. It can also be file content from a binary file such as TDMS or PNG image data, as well as HTML content that's dynamically generated with string manipulation, JSON representation of data, XML representation of data, and anything else that a connected client may understand the format of. Any content that may change after initially deploying a web service must be served by a resource VI. The static files that are included as public content in a web service cannot be updated after deployment. The two best options for responding with data from a web service are terminals with JSON formatting or the stream option with both options checked. Web services can be sent parameters to change how it generates responses in several ways. In this presentation, we'll be looking at GET parameters, which are also known as query or URL parameters. These are found after the path portion of a URL and usually take the form of a question mark followed by key value pairs separated by the ampersand. This format of query strings is not enforced and can actually take any form, though this is the common convention. G Web applications also have several ways of retrieving data from web services. The most common of which will be to use one of the HTTP method VIs to request a specific resource from the web services. The technique we'll be looking at for most of these demos will be to generate a URL that represents an image we would like to display. So let's take a look at our first demo. In this demo, we have a really basic G Web application which is meant to request and display a random number generated by a web service. Here on the left, we have our LabVIEW project with a handful of web services we'll be looking at one at a time, and here we have a random number web service. In this web service, we've got a web resource VI called random number, in which we generate a random number to send back to the client. Then our client, in this case our G Web application, will receive that value, interpret the JSON formatting that it was sent in, and display that on the front panel. The easiest way to test web services and start them running is to right-click on the top-level web service entry and just select Start from the menu. Those that have previously seen web services may be familiar with the application web server, which has its own entry for how to run the web services. However, application web server is being deprecated at some point, and all web services should use the NI web server whenever possible. So we'll go ahead and we'll get this started, and then I'll come over to G Web and run this application. And every time it runs, we can see the JSON format of the response and that we are properly extracting that value from there. So JSON is a really good idea for returning web service data from, as it's a well-known format and can work with a variety of JavaScript code and web applications, even outside of G Web applications. So as we can see in this string value, if you're familiar with JSON, it's encapsulated with these curly braces, which signify an object. And then we've got key value pairs, where we have the name of the field and then the value of that field. Similarly, on the block diagram, we have a cluster. This represents the curly brace portion of the JSON data. And then within that, we've got a field for the numeric value. If we look at the web service configuration, we'll have to go ahead and stop it to take a look at this. So I can right-click on it and go down to Properties. We can then see the Web Service Properties dialog. I'm going to go ahead and select the HTTP method VI settings. And here we can see the one VI we have as part of this. Now this uses all of the default options. And in the Output Type tab, we can see that it is left as terminal, with an output format of JSON. Now, looking back at the VI, what this means is that any controls that we attach to our connector pane will become part of the output data that's sent back, and it will have fields corresponding to the labels of those indicators that are wired to the connector pane. For our next demo, we'll take a look at how we can use web services to dynamically generate images to be displayed in a G Web application. For this example, we have a G Web application where we can provide a number of parameters for a waveform generation, and then an image field that we expect to display that in. So this image field is available from the decorations palette, and it's just a URL image. The normal usage would be to enter a URL to an image available on a web server somewhere, and it would immediately display that. However, we want to preview some dynamic content in this web application. To accomplish that, we've got a web service over here, in this case called gweb-image, and we've got a web service VI here that has familiar looking parameters available to it, as well as a little chart that we'll be using to generate our image. In this web service, we are using the parameters that are specified by the request, as well as formatting them into the specific values we need in the LabVIEW code. And then we're using a waveform generation VI to populate some data into this waveform graph. We can then use an invoke node with the getImage method to turn that front panel controller indicator into a picture that we can then translate into PNG image data and stream back directly to the client. When doing this, it's also a really good idea to set the content type field for the response. And when using the streaming value, if we look at this web services properties, we can see that with this method VI, we have the output type set to stream. None of the other formats would be appropriate for this, as we are trying to send back already specifically formatted data. So if I go ahead and get this web service started, and then run this G Web application, I can go ahead and get these filled out. And there we get our image preview. I can go ahead and increase the frequency, and we can see the wavelength of those cycles getting shorter. I can change the shape to square, back to triangle, or a saw. We can also see the URL that this web application is generating in order to request this specific image from the service. On the diagram, I've got a sub-VI here where I pass in the 4 parameters that were specified by the user, and then we're generating a URL that is, we're both displaying the actual string of the URL, as well as plugging that in to our URL image terminal. With this technique, we can change which image is loaded into a URL image on the block diagram. In this sub-VI, we are taking the 4 individual parameters and using them to build a URL that corresponds to the image we want to display. Generating dynamic content is great. However, that does mean that the LabVIEW code has to do a whole bunch of work every time that image is requested, even if it's one that's already been requested, or that image is supposed to last for many requests after it's generated. For this use case, where we want to generate an image and redisplay it multiple times, such as if we're starting a test and generating data that only corresponds to the start of that test that may run for weeks or more, and we just want to keep redisplaying that same data, we can use file I/O to save that data to disk, which we can then retrieve from disk in subsequent requests, which will be much more efficient. When following this technique, it would be very helpful to return 404 or 500 status codes to the client so that it knows there was a problem in generating the data. This brings us to our next demo, where we'll look at how we can generate these images, but then save them to disk in a way that we can access again in subsequent requests. For this next demo, we'll actually use the web browser to demonstrate these capabilities. I'll go ahead and get this web service started, and this time we can see I have two different VIs that will respond to requests. We have one that looks almost identical to the previous example, except that this time we're saving it to disk with a specific path, which we're saving relative to our project, or if this was built into an executable, would also be saved relative to that executable, instead of just sending it as a response to the web service. Then we've got a second resource VI where we will open that file, so we're going to build the same relative path. We're going to open that in binary form and send the data to the web service. However, if the file does not yet exist, we'll send back a 404 response, and we'll even send the error message with it. So one of the ways that we can easily get the URL to access these VIs with is if you right-click on a VI, you can select Show Method URL. Since we are in fact running these on our NI web server, I'll just go ahead and copy this URL and close that dialog. One thing to note is that when that dialog is open, web services will not respond to requests, and you may wonder why things appear to be hung. So I'm going to go ahead and open up Edge, and we'll paste that URL. And we can see the error message that is displayed. This is a demo. If this is a production web service, an application that I was building, you would not want to respond with error information like this. This is going to divulge information about the system that is running this to the users, which maybe they're internal users and it's not a big deal, but especially for public-facing web servers, this would be a very bad idea. It can also open your system up for other attacks, such as cross-site scripting, CSRF, and a handful of other web security concerns. So this is useful for us debugging our application, but when we get ready to make this available for everybody else, we do want to remove any kind of information sharing like this from our application. So now that I've demonstrated generating an error response when an image isn't available, let's take a look at the other resource. I'm going to go ahead and show its method URL. I'm going to copy this, close that dialog, and now let's fill in some of these values. When it shows you the method URL, it'll put these placeholders in that we need to substitute with our own values. So I'm going to go ahead and fill these in with values that will work for this. And now this save image resource does not generate a response itself, but now we should have an image that we can display with getImage. And as many times as I refresh this content, it's still the same image. So this will run much more efficiently because the LabVIEW Web Service is just serving content from a file. We can then go back to this and generate a different shape. So let's do a square so that stands out better. Let's increase the frequency a whole bunch, and we'll make this request. One other thing you can do when you are testing resources like this, which do not generate a proper response, is you can hit F12 in most web browsers to bring up the developer tools. And if I hit enter to make this request, we can see it show up here in the log. So we can see all the information relevant to this request, such as the full URL for it, including all the parameters we had entered, and what the response is. In this case, we get a 200, which usually means things worked. With the previous demos, we've seen how we can easily run web services from the LabVIEW project and run G Web applications within the G Web editor, as well as test the web service endpoints from a browser directly. However, we can generate actual built applications that will run our web services for us, and we can even package our G Web applications with those. There are several options for deploying G Web applications, such as creating packages or installers from the G Web software itself. G Web applications can be deployed to SystemLink and SystemLink Cloud. You can also deploy G Web applications to your own web server, and the solution we'll be looking at is to add a G Web application as the public content of a LabVIEW web service. Web services can be deployed in a handful of ways, such as building them into a LabVIEW application, which is the example we'll look at, and you can also create packages and installers for the web services that will automate deploying them to a NI web server. If a web service is exposing data from a LabVIEW application, such as a test application, or you've got some control software that you want to be able to interact with from the web, it makes sense to package that G Web application with the web service, and then they'll both live together. So let's go ahead and take a look at this demo and how we can set that up. We'll go ahead and we'll preview this demo by first running it from the project and looking at the G Web application directly in the G Web editor. So just like the last ones, we're going to dynamically generate an image, but this time we're going to generate a polar plot. And we'll see the line plots that it is generating based on the data that we're supplying. So we've got this little plot here. We can see the URL in this one that's being generated, and in this case, we see a whole bunch of extra stuff that doesn't look like any of the data that we've been generating before. All of these percents and then 2 characters following it is what's known as URL encoding, and in this case, this corresponds to the hex value of the ASCII characters that we are replacing. This then becomes safe to transmit as a URL request, and the server software receiving it can turn that back into the original data. In this case, we're turning this array of our magnitude and phase values into JSON and then sending that as encoded data in the URL for the image. This makes it real easy to just take our points cluster array here, pass it through the flatten to JSON method. We're then going to perform our URL encoding. This is not something that is built into G Web. I did have to write this. Additionally, if you search for a URL for WebVI package, there is one available on the NI forums. I am then going to add that to the URL that's part to form that request, and we're going to update our URL image's value with that new URL source. So now that we've taken a look at that, how do we get this packaged and ready to embed in our G Web application? So if we double click on our G component here, which represents the whole G Web application, we're going to get the properties page for that G component. Then this hammer icon will let us build this into a deployable folder. So here we can see it succeeded down here at the bottom of this list. I'm going to go ahead and right click that and select Locate Item in Windows Explorer. These here now are all of the files that are necessary to run this G Web application. We're going to create a public content folder that we can embed this G Web application into for this web service. So since it's running, I'm going to go ahead and stop it, and we're going to add a public content folder. I'm going to go ahead and name this NWS to match our G Web application name. and this will be the folder we use to store our GWeb application. So I'm going to go ahead and right-click that again, go to Explore, and now I can copy our GWeb files into that folder. They'll then show up here in our LabVIEW project to let us know that it did pick those up. Now, if I go ahead and run this again, and I want to right-click on this index file and choose Show Public URL, we'll go ahead and copy that and pull that up in our browser. So we are now loading the GWeb application generated content in the web browser served directly from our web service. So we can go ahead and plug some values in here, and we can see it is still generating this data for us, this image for us. So this is great. I'm now getting access to both the web services and the GWeb application from the browser. But how can I run it so it's not being run directly from my LabVIEW project? So if we go ahead and stop this, the other thing I've already created in this web service, it's actually outside of the web service, so I've just got it in this same virtual folder as my web service. Where it is in the project doesn't matter. I've got this top-level VI that I intend to run as the application, top-level main VI. This really doesn't do anything other than stay running so that the web service stays deployed. So I've just, in this VI, have an event case that's the event will stop running when I close the panel. The only event here is this panel close. Normally with a LabVIEW application, you'd probably have some other application logic here where you're going to run local user interfaces and any of your test logic or control logic that you may be performing. So I've already made the build spec. So let's go ahead and clear that out so we can see what generating this from scratch looks like. So I'm going to create an application that I'm going to name drawPolar. The name isn't important. I'm just, in this case, going to match the name of my web service. And we'll go ahead and a nice lowercase name. So in my source files, I'm going to go ahead and pick that exe, that drawPolar exe VI. And again, the idea there is the application will automatically deploy the web service content when it starts up, and then whenever the application shuts down, it will automatically undeploy the web service. So we need something to remain running to leave the web service available. I'm then also going to go down here to the web services category of this build spec, and we're going to include that drawPolar. Since we do want this to deploy to the NI web server, we're going to leave that checked by default. So I can go ahead and build this. And then we'll go ahead and explore to it on disk. So here we can see with this executable, we've got this LVWS file sitting alongside it, and this is the packaged web service that our application will be able to deploy to the NI web server. For this demonstration, I'm going to go ahead and close everything else down, just to show that it is actually running from this application. So there we go. LabVIEW is closed down, GWeb is closed down. I will run this executable. And if we watch closely in the taskbar, we'll see another icon here show up and then vanish again. And that is the application deploying the web service to the web server. So I can once again come into here and enter the same URL just as before. And we'll pull up that index page. And here is our application. Here is our GWeb application now being served directly from our LabVIEW application executable. And there you go. There's a nice kite to wrap up this presentation.